Okay, we're going to start with consumer theory. We're going to look at the budget constraint. This will lead eventually to the demand curve, and very important in market analysis of microeconomics. Textbook definition of economics is how to choose when you can't do everything. And I refer to this as like kind of the suitcase problem. Basically, how do you fit whatever you want into a suitcase? I think there's a limit of 23 kilograms for international travel. It's going to depend on where you go, but also there's a limit. So we say it's an optimization problem. In effect, you want to get the most you can in the limited space available. Another example of a problem like this is, say, Dawson College has to decide how to schedule students. There's a limit in the number of rooms available, classrooms. They want to get as many students as possible in as many rooms, but the constraint is the size of the classroom, the number of the classrooms, and of course the time available as well. In consumer theory, we refer to this as a maximize utility, which is the happiness factor, if you will, given a budget constraint. There's only so much money available. So you might imagine this is going shopping and grocery shopping, and you have to decide what you're going to put into the cart, given the amount of money you have in your wallet. We can show this mathematically in the following way, and this is how it's done normally in microeconomics. Is U represents utility or happiness. We've got a variety of goods that you can purchase, X1, X2, X3, and X4, and so on. This is the objective function, and it's subject to a budget constraint where I'm using R as the money available, and these are the prices of the various items. And this is the amount of money available to spend. Let's take a look at this in a graphical terms. I won't be doing this mathematically, at least with equations, but I will be doing it graphically, so that's what we'll illustrate next. Let's consider a case, simple case. I've got my nephew, and he's coming to visit me in Montreal. His mother, my sister, gives him $20 to go to McDonald's, and let's say, for the sake of argument, that he can buy a Big Mac for $5, and he can buy a McNugget for $1 each. And which means that, in effect, he could spend all of the money on Big Macs to be able to buy 4 of them, or he could spend all the money on McNuggets. He'd have 20 of them. So graphically, what we've got here, I'm just going to put arbitrarily the McNuggets on the horizontal axis, call it X, put Big Macs on the vertical axis, and as you can see, he'd be able to buy 4 Big Macs. They'd spend all the money on Big Macs, or he could spend all of the money, $20 on McNuggets, he'd be able to buy 20 of them. Or, in effect, he could choose anywhere on this orange line, and this, in effect, becomes what we call the budget constraint. I'm assuming here, too, that he could buy half a Big Mac, for example. And actually, these are units. These are integers. So there's a whole theory in economics about that situation. I'm exempting that by assuming that you can buy a portion of a Big Mac or a portion of a Big Nugget. You note, too, that anything out here, for example, this point, well, he doesn't have enough money for that possibility. So this is why it's a constraint. A situation like this inside, where, for example, the term we use for this, by the way, is a bundle. So we're looking at various bundles. You can imagine it as a basket of goods or a bundle of goods, 1 Big Mac and 5 McNuggets at this point particular here. It would mean that he doesn't spend all his money. So if he spends all his money, he's going to be on the budget constraint, the orange one. But he could, in effect, be saving the money to purchase something else or something later. Now, I want to make several points about this idea of a budget constraint, key points in terms of the analysis we'll be doing later. Is that what happens if we give him more money? Let's say he's got $30 instead of 20. So I've redrawn the budget constraint as we had it a moment ago, where he can buy, for example, 4 Big Macs, and he can buy 20 McNuggets if he had $20 maximum to spend. Here I've re-indicated the prices, and now I'll indicate the price of a Big Mac is $5, the price of a McNugget is $1, and I'm going to use the letter R representing the money available. So let's say we change this from previously $20, and we're going to raise it to $30. So now, in effect, what he can do is he can buy 6 Big Macs, and he could purchase, if he wanted to, up to 30 McNuggets. So the effect of this is to draw a whole new budget constraint that, in effect, shifts over. But you'll notice something very important, and this will become important later. We do what's called welfare analysis, is that the slope of the budget constraint doesn't change. All that happens is what was previously he couldn't afford to purchase, now he can. So that's the first point I want to make, is that we say a change in income, meaning to say there's more a relaxing of the budget constraint. What happens if we change the price? So in this case, I'm going to consider the possibility that the McNugget now is, let's say, $2 instead of $1. So I'm going to change this to $2 here, which means that this will now be $2. But I'm going to keep it at, go back to the situation where he's got 20 bucks to spend. So this as well, we'll have to change this to 2. You'll notice now I call it PY and PX. Keep in mind, X is McNuggets, Y is Big Macs. I've left the price of a Big Mac exactly the same. Well, in this case now, if a McNugget is $2, he won't be able to buy 20 of them. He'll only be able to buy 10 of them, maximum. Of course, he'd still be able to buy the 4 Big Macs. So I've indicated it down here as 10. And now we can draw a new budget constraint. You'll notice in this case, the slope changes, and that's actually a very important point. The budget constraint kind of shifts down. Of course, if he doesn't like McNuggets, it really has no effect on him because he's going to be buying all Big Macs. That would be this case up here. But important to note that if we change a price, one price, of course, change both prices by the same proportion, that's actually like giving less money. And that's another important point, by the way, we'll look at later. So what do we mean by the slope of the budget constraint? So in this case, I've kept the price at $2, like I made the price change a moment ago. What is the slope? Well, mathematically, if you think about it, if we're up at this point here, we're 4, we change in y, be a change in x, so the slope is defined as change in y divided by a change in x, which in this case is minus 4 divided by 10, which you'll notice something very important. It's equal to the price of x, which is 2, divided by the price of y, which is 5. This we can put the minus sign in, but it's not necessary because we know in economics that the budget constraint is negative, has a negative slope. So this is actually a very important point, is that we can write the slope of the budget constraint as merely being the relative price or the price of y in terms of x. Actually, this is the price of good y in terms of good x. I think that's reversed. That should be the opposite. So that's the third point. And this will come back to this, is that the budget constraint is, the slope of the budget constraint is equal to the relative prices of the two goods on either axis. Next point I wanted, what happens if we add another good? So you can go to the McDonald's and you can buy Big Macs, you can buy McNuggets, and let's say, for example, he can also buy a drink, let's say a Coke. So how would we illustrate this on the graph? Well, what we'd have to do now is we'd have to add a third axis. You notice now we've got 3 goods, so it's a 3-dimensional object. Here I call it Z for drinks, for Cokes. And let's say, for the sake of argument, that a Coke costs $2.50, in which case if he spent all 20, we've gone back to the $20 case, where that's the amount of money in his wallet, he could spend it, he'd be able to buy 8 drinks. So I can show this here as 8, this point, and this would mean he'd spend all his money on Coke. He'd have 8 drinks, but he'd have no McNuggets, no Big Macs. So now the budget constraint, in effect, is going to turn into a 3-dimensional plane. I can illustrate it this way. I could have a situation where he only buys Big Macs, he only buys McNuggets, 20, price is $1 each, or he buys 8 drinks. But in actual fact, he could choose a combination of all 3 of them, which, as I say, the budget constraint in this case would be a 3-dimensional plane. And again, he could potentially be at a point inside here, but in effect what that would mean is that he's not spending all his money. He'd be saving it for buying something later. Incidentally, if we add a 4th object, then it turns into something called a hyperplane, which is a surface area in more than 3 dimensions. I can't draw that. And even drawing 3 dimensions is not that good, so I'm not going to. I'm going to stick, in general, with the idea of having just simply 2 goods. It makes it easier to draw, as long as it's understood that it would not be difficult to analyze this with more, which, of course, is closer to the real world. People have a myriad items that they can purchase if they want to. Let's take this idea and apply it to something very different, not Big Macs or McNuggets or something. Let's consider the possibility of work versus leisure. Now, in this case, I've got leisure is something that's good, people like, and here you can work and make money, and then you can purchase stuff. So in this case down here, well, let's take a look at it. What do these numbers mean? This point up here, $240, well, the person's got 16 hours available. If they have no leisure at all, in a day, 16 hours in a day, that would mean that they'd be working full out, and in this case, the salary is going to be $15 an hour. I know that because if you take $15 an hour, you work for 16 hours, then you'd have $240. Now, another thing you could do instead is not work at all. So this is no leisure, and here is no money. So, and down here, you'd just be sitting at home watching TV or playing video games or something, but you wouldn't have any money to purchase. Now, you can pick some point along this orange line, which would be, say, a point like half and half, a point like this, for example, where, in effect, what this means is the person would have 12 hours of leisure, and that means to say they would work for 4 hours. So you can sort of imagine work is equal to 4 hours, and that's at $15 an hour. And that means they would have $60 or money available to purchase stuff. Keep in mind, too, that people don't want money just because of money. They want to use it for something, and that means to say we've got stuff over here on the vertical axis. Let's consider another possibility. Incidentally, what would happen if there was a tax, an income tax? For example, let's say the income tax is 50%. Well, that means you wouldn't get all $240, and so as a result, this new budget constraint, I have to draw it down here, it would be something like this, where if it's a 50% tax and you worked for 16 hours, you wouldn't keep 240, you only have 120. Notice something important about this tax idea is that for somebody that stays at home and doesn't do anything to watch it, the tax is irrelevant to them because they're taking all 16 hours in leisure. And it's actually a very important point about the tax system is that it changes the slope of this budget constraint. We'll look at this later too, because the term in economics for this is a distortion. Let's consider another possibility, the idea that you work and you can consume your earnings. You win a lottery, let's say. You win a lottery in this period. This is period 1, let's say, the first part of your life, or this year, and then 2 is next year, and then you die. So what are you going to do with this lottery winning? Well, in effect, you could consume it all down at the bottom here, which would mean that you'd have nothing, no consumption for the future. An alternative would be, of course, you save it all, and then you consume everything, but I don't know how you'd be alive next year because you wouldn't have been able to consume anything. So an individual could choose to be somewhere in between the two. For example, let's say a point like this, where the person would choose to consume half of the lottery winning this year and then save half of it for next year before they die. Incidentally, in macroeconomics, this is how we go about analyzing the idea of an individual, how they make the decision between consuming and saving. A little point to consider here, though, is what determines the slope? That is to say, if you're at this point here, for example, where you choose to consume half of your lottery winning this year and save it for the future, is it really true that it's going to be a straight line? If you think about it a little bit more, is that this is going to move outward a little bit. You have a slope like this because of the interest rate. In effect, if you were to save your money this year and not consume it, and you were to invest it, then you'd have a return on your investment, and that would allow you to have a larger future consumption than you would have now. This, of course, becomes relevant in macroeconomics. I want to finish with this last idea here. This is another example. Imagine that you can buy an STM Pass. Well, let's first of all start with the idea that you have $300. Let's say a student has $300 available as their disposable income for 1 month. And let's say each trip on the metro costs $2. So I've put it down here, and I've got X as the number of metro trips. Now, on Y, I've got all the stuff you can purchase except for metro tickets. So that means to say, if we look at this, the student could be up here at 3 and make no metro trips at all. Maybe the person lives right beside the college. They don't need to take the metro. So they'd have $300 to spend however they want to. And alternatively, of course, is a student could make 150 trips. Each trip is $2. Of course, then they would have no money for anything else. They'd be riding the metro all day long. Or they'd be riding the metro frequently, 10 times a day in a month. Now, we can draw a budget constraint like this, and now the student can choose to either have metro trips or money to spend on other stuff. So you could pick a point like this here, for example, make a lot of trips or make a few trips, however they wish. What happens if we introduce now the idea of a monthly pass, like a student pass, where in effect you can make as many trips as you want to once you have this pass? Well, if you think about this, if you purchase the pass, then you'll only have $250 available for other stuff. So I can show that here, like this. And then what would happen? You'd be able to make as many trips as you wanted to. So now the budget constraint would look like this. In a sense, if the student knew that they were going to be making fewer than 250 trips, or rather, if they could plan in advance the number, you could sort of say that the budget constraint has this shape to it. Of course, once they purchase the pass, then it's just this whole line like this. So in effect, what this means is the way we draw the budget constraint is going to depend on the circumstances, the price, and things of this nature. We haven't gotten to the point of where the person chooses what the individual chooses to, where the student will be, or where the person who wins the lottery would be, or where my nephew, how many Big Macs and McNuggets he's actually going to purchase. Budget constraint tells us the limit of what you can do. The next step is to look at the objective function that the person wants to maximize.